Our topic for today's discussion is first scalar quantity. This is also a very important topic, children. Scalar quantity. We have in chapter number we have discussed about physical quantities that can be counted, that can be measured. So this physical quantity, these are grouped into two categories. That is the scalar quantities. Some are scalar, some are vector quantities. Are you listening, me children? Am I audible?
Yes.
Yes, sir.
Thank you.
Yes, sir.
So here, the first topic, that scalar quantity. What are the scalar quantity in physics? How to explain, how to know what are scalar quantities? Now let's see here. A quantity with magnitude and no direction are called scalar quantity. With magnitude, means these are the part of the physical quantity. We can measure, we can calculate. They have magnitude. You know, children, what do you mean by the magnitude?
Size.
Magnitude means, sorry?
Size.
Related to their size, related to their dimensions, and this is something like their some measuring value. For example, if I write distance is equal to 25 kilometer. What is this 25? This 25 is the magnitude of distance, the size of distance, numerical value of distance. So any quantity having only magnitude but no directions, so we cannot specify directions, and that quantities are called a scalar quantity. What are the examples for scalar quantity? We have so many quantities in physics that are scalars and that are vectors. For example, one is the path length, another one is the speed, another is the distance also, work also, and so many. Density, volume. The chapter number 1 we have discussed density. What about the density? Is it a scalar quantity or vector quantity? Volume is a scalar or vector. So path length and speed are an example of scalar quantity. What do you mean by path length? What do you mean by speed? That we are going to discuss in today's class itself. Now move to the vector quantity, children. In vector quantity, that is something, one more term added into the vector quantity, that vector quantity, they have magnitude. They have magnitude. Scalar also have magnitude, means they have some, their size is there. We can measure their values. But one thing that we have with vector quantity are directions. You know, the name suggests vector. You know, vector means it's a vector, the sign of arrow, direction. It is related to the direction also. So direction is very important, and whenever we can specify the direction of a moving object, so that is considered a vector quantity. So here, children, that you should remember that the meaning and the difference is scalar quantities having magnitude only but not directions, and other hand, vector quantities, that direction is important here. Definitely magnitude will be there. Magnitude will be there, and direction should be specified. So whenever we are going to discuss about vector quantity, whenever we are going to write any information about the vector quantity, you children, you have to specify direction. For example, just for example, if I say a car is moving with some certain kind of speed is 50 kilometer per hour, 50 kilometer per hour, 60 kilometer per hour, and speed, you know that it's a scalar quantity. What is the magnitude? 50 kilometer per hour. Direction, we are not specifying direction. Speed is a scalar quantity. But on the other side, if I say velocity, that a car is moving, you're riding a car, you are riding a bicycle, you are driving a car with the speed of 80 kilometer per hour, and then you have to specify that the car is going towards Mall of Indonesia. It is going toward the South Jakarta. It is going in one particular direction. That direction is very important for a vector quantity. That is the meaning of, that vector quantity always have a direction. Examples, this displacement and velocity are the example for vector quantity. So let me move to the other slide. Now, children, let's discuss about the path length and displacement. Now, in the previous slide, that here, the one of the quantity, path length is a scalar and displacement is a vector. Path length is a scalar quantity, displacement is a vector quantity. How they are scalar and how they are vector. Now, let's discuss that. Let me begin with the first, path length. And may I ask to Satria, do you know the meaning of path length? How can you explain it? Path length.
It's not the same as distance, right, sir?
It is the same as distance.
Oh, never mind then.
Distance is called a path length. So I'll just explain what is distance.
It's how long it takes for a path to reach from one point to another. Or like the distance between 2 points.
Yeah, the distance. Okay. So now listen carefully, children. To understand the meaning of the path length, the exact meaning and the definition of path length, just see here. Our path length is basically the distance traveled by an object from one position, that is the initial position, to some final position. And for example, I'm not going to the displacement right now. I want to discuss something about the path length here. And here in this diagram, one example you see here, home, and someone want to move from home to college, or maybe that someone want to move from your house to your girlfriend house, from one home to another home. So in this case, I think that let me show you that. Now you can see that boy, he's riding this cycle and he's moving from home to college, from one place to another place. Now in this case, if I draw a line here, that this person, he started, suppose, from give me a moment, sometimes this pen doesn't work. Now, in this case, children, that this boy moved from home to college, from one position to another position, and we have to understand the meaning of the path length here. To explain the path length, let me draw a line here, and this has moved to this point from home to college. So the total distance traveled by any object is called its path length. So this path length, it can be linear, it can be in 2D, it can be in 3D, it can be circular motion. So whatever the path, actual path traveled, listen carefully, children, listen carefully, path traveled by any object. Path traveled by actual path length, that is called the distance, or in terms of path length, that the total distance traveled by a person from one position to another position. Please remember this carefully. This is a very important meaning, definition of path length, total distance, or in terms of what is distance, the total path or actual path covered, traveled, traced by any object is called path length. And here we are not constant, or we are not bound with that we have to specify direction. No, that the person is moving from home and to college. not any direction. It's a path, it's a scalar quantity. So we cannot specify direction, and there is no need to specify direction. In what direction the person is going. Now on the other side, displacement is more interesting, more important than the path length. And what is this path length? And students get confused in the displacement term. Shortest distance between initial and final position. Shortest distance between one position to final position. Now here, if I draw another diagram, suppose, let me take one example. Aaron started moving from his house, moved 2 kilometer distance to a certain direction, and when he reached to some point, maybe to the GMIS, at that point he turned with an angle of 90 degrees, maybe to the left, maybe to his right, and now he covered this much of distance, path length 3 centimeters, not sorry, that will be kilometer, the same unit. Now in this case, the Aaron is now at this position to some new position, and maybe like a coffee shop. Now in this condition, may I ask you children, what is the total distance traveled by Aaron, moving from home to GMIS and then to the shop? Total distance. Rishikesh Nair. What is the
5 kilometers.
5?
5 kilometers.
5 kilometers is the actual path length. That I am okay with this, your answer, that it is correct. Now, if I ask the same question, children, but you have to find out what is the displacement. What is the displacement traveled by Aaron? Now let me ask to Aaron. Aaron, please. How much is the displacement traveled by you as per the diagram? Definition states it is the shortest distance between initial and final position.
So then you can use trigonometry, right?
You have to use a trigonometry, correct? So
Yep.
in this case, it's a trigonometric term, children, yes. And now it's the shortest distance between the initial. This is the initial position. This is the initial position. What is the final position? Final destination is this. Join initial and final position every time, children. Join initial and final position. And when you join initial and final position, mathematics states you will get always a straight line. You will get a straight line, children. Displacement always gives you a straight line. It always, suppose instead of moving in a straight path, like rectilinear path, your path is like this along the curve. You move from A to B. To calculate distance, the actual path length, you have to calculate the length of this arc. But if I ask you, find the displacement. So in displacement, what do you need to do, children? Remember and listen carefully. You have to focus on the initial position. You have to focus on the final position. Join them. And that will be this. Join initial and the final point, and you will get a straight line. And this is the shortest distance, that is called the displacement. And whenever you are defining displacement, direction is important. Now I have taken the example of Aaron. In what direction Aaron is moving? You have to specify east, west, north, south. Direction is important. Direction is important. In this case, this boy, in what direction is moving? To the West Java, to the North Java. You have to specify, or that the boy is moving towards college. That you have to signify, you have to specify directions whenever you're dealing with the vector quantities. Now I want to move to the next topic. There is no need to spend so much time on it.
Sir,
Yes, please. Now, okay.
For the trigonometry part in this question about Aaron going to GMI's and then to the copy shop, is that the tangent function? Because we have the opposite and adjacent.
Here in this, if you want to find the displacement of Aaron, I forgot to tell you, in this case, how can you find out? You have two methods. The one, you just use a scale, a ruler, find the help of a measuring tape. If the distance is small, you can use the measuring length. You can find that this distance, whatever this distance comes, with the help of scale. Okay, with the help of scale, whatever this value comes. Otherwise, you can use the trigonometric equation. You know the Pythagoras theorems. You know the Pythagoras theorem, children?
Yes, sir.
Yes, sir. A squared plus b squared equals c squared.
Yes, sir.
Perpendicular square plus base square. Right square plus run square. You know that's the equation. So with the help of that equation, you also calculate the displacement. To calculate the displacement, in this case, when you have a trigonometrical shape of path, in that case, apply the Pythagoras theorem. Otherwise, generally, here in grade 9 and 10, we suggest just use scale. Whenever you find some questions in your exams, you have to take the help of scale and measure that, whatever the distance, whatever the length is covering. That will be the answer. Here in the slide, they also mentioned about the displacement. Finally, that this boy on cycle that you can find, he's on the McDonald's, and if it is he's there, and so you can find path length will be the actual path, the total distance traveled by this boy home to college, college to McDonald's. And in terms of displacement, that will be the shortest distance between 2 points. It is not the longest, it is the shortest distance, children, which always come a straight line. Home to McDonald's, that is the displacement. Now here, path length, there is one more point. Okay, children, here in this, path length is equal to displacement. There is a possibility path length can be equal to displacement. And there is one situation. And what is that situation? When path followed by any object is rectilinear or a linear path or a straight path. In that situation, path length is equal to the displacement itself. Are you getting my point, children? Path length will be equal to the displacement in a situation when object moves in a straight path. How? Now see here. Again, the same example. This boy is moving from one position to another position. And suppose, let me write here 5 kilometers. He has covered this distance from home to McDonald's, 5 kilometers. If I ask you, what is distance? 5 kilometers. What is displacement? Initial position is this. Initial position. Final position is this. Actually, let me write. If you join initial and final position, you are getting the same straight line, and that already calculated the path length, which is 5 kilometers. So 5 kilometers is the distance, 5 kilometers is the displacement. But remember, displacement is a vector quantity. Then you have to specify that this boy is moving toward the McDonald's. Otherwise, magnitude is same. So magnitude of distance and displacement will be same in a condition when the object moves in a straight line path. Otherwise, it is not possible that distance and displacement can be equal. Now, how? Let me show you some more things here. Yeah, here. Now, another important information about the path length is, children, path length never equal to 0, but displacement can be 0. Please remember and listen carefully. Path length is not equal to 0. Means if any object moved, changes its position, whether it is a very small, it is a micro millimeter distance is traveled, path length is not equal to 0 because object has changed its position. There is some actual path. But displacement can be 0. How? How displacement can be 0? Now see this diagram here, children. In this picture now, just focus here, and then this boy moved back to, after some time that this boy is returned back to the initial position. Now in that case, what is the path length? Path length will be distance from home to McDonald's, McDonald's back to the house. That is the path length. But displacement, what the definition states, shortest distance between the initial position and final position. What is the initial position? House. What is the final position, destination? That is house. Join these points. Both the points are coinciding. So there is no distance actually between. So there is no displacement. So basically, children, whenever object return back to its final position, displacement is 0. Let me give one example. Instead of this example, let me take a circular motion. Circular motion, you like the athletes. You know, recently that we have seen the Olympics games in Tokyo. Now, and we have a track of 200-meter race. 200 meter. So I want to draw a track. Something like that. It's a track. And the player are here, you know, the athletes are here. This is the starting point. And at the sound of whistle, you know that the athletes, they start running, they run. Consider this is circular track. Consider this is circular track, even that I have not shown it's a circular, but consider it's a circular track, and they return to the final position after a certain time. So consider that the radius of this path is 5 meter. Just let me take a simple example. It's a 5 meter radius. So yeah, now the question is, you have to calculate path length in this case. And then the second is you have to calculate displacement. The question mark. You have to calculate path length. So as we have assumed that this is a circular track and I have to calculate path length. So path length means that the total distance covered by athletes. So how to calculate? You know, this is circular path. It's a circular track. So I note that the equation of circular path, circumference, that is equal to, given by mathematical equation, 2 multiplied by pi multiplied by r. Radius is given. So that answer is 5 to the 10 pi. You can put the value of the pi also. And that is the path length. And now you have to calculate the displacement as well. To calculate displacement, you know, children, that we have the equation, that statement you have to remember, shortest distance. Join the initial and the final point. Initial point is at point A, final position is at point A. So displacement, your answer will be 0. And it states that path length is not equal to 0. We have put 10 pi, but displacement can be 0, and we have got the answer that displacement is 0. Shall I move to next slide? So more information about this magnitude of displacement may or may not be equal to the path length traveled by an object. Yeah, it may be equal. It may not be equal. When it will be equal? In a straight path. Unequal, we have seen here in the example of a circular path, it can be 0. Path length is not 0. Please remember. Now, next, some few questions for practice, children. And this question.
Can you go to the previous slide? I need to take screen.
Okay.
Okay, sir. Thank you.
In short, children, you can write path length can be 0. Sorry, path length cannot be 0, but displacement can be 0. Now this question is for, let me find, Abhinav. Abhinav Dinesh, please get ready for this question. Correct statement among the following is. Have a look on all these 4 statements. Other students, you also go through.
Okay, sir.
When displacement is 0, distance traveled is not 0. You have to find the correct statement, okay? When displacement is 0, distance traveled is also 0. In option 3, when distance is 0, displacement is not 0. Distance traveled and displacement are always equal. Now, may I know the right answer? Vansh and Abhinav, both of you.
Sir, is it number 2?
You think about it. Displacement is 0.
I think number 1.
Number 1. Now let's see what the answer. Number 1. Now, Abhinav here, what mistake you have made here? Aaron, yes, your answer is also correct. Now, Abhinav, you said when displacement is 0, we have seen in a circular track, displacement is 0. Definitely displacement will be 0. But the second half of this statement, distance traveled is also 0. How distance can be 0? If object moved, athletes moved, so distance cannot be 0. Abhinav, you please pay attention.
Okay, sir.
Yeah. Next question, number 2. Numerical ratio of displacement to distance is a mathematical question. Think about this situation. Numerical ratio of displacement is in numerator, distance is in denominator. What are the possible answers? Always less than 1, always greater than 1, always equal to 1, maybe less than 1 or equal to 1. Rishikesh says this is answer number 4. Okay, Kajan, may I know the answer?
I think 4 too, sir.
And what about Ashdeep and Sneha?
Yes, sir, I think it's number 4.
Number 4 and Sneha?
Sir, I think it's number 4.
Number 4, yes, answer is correct. It is number 4. Now, let me explain numerical ratio of displacement. In displacement, we have seen that it can be 0 divided by like this. This distance will be there because distance in the numerator, it is a positive term, distance. And if displacement can be equal to, distance, so 1 by 1, that situation. So basically, it can be less than 1, I can consider, and it may be equal to 1. Displacement can never be greater than distance. Maximum, it can be equal or less than. Kezia, yes, your answer also correct.